Okay, so the question is to solve e to the x plus e to the negative x equals 5. So first thing we do is get rid of all the negative exponents. So actually, let me do that with a different color. There we go. So all the negative exponents, you know, e to the x stay obviously e to the x. E to the negative x can then become 1 over e to the x, and then equals 5. And then in order to solve these, again, remember the greatest trick is to try to always get rid of the fractions if possible. So I'm going to actually multiply everything. I put those over 1 just to make it a little bit more clear. Multiply everything by e to the x because that was the LCD everywhere across the board. With that in mind, then, we can go ahead and reduce things. E to the x, this part right here, this e to the x times e to the x, this portion will turn into now e to the x squared, just like how x times x becomes x squared. E to the x times e to the x becomes e to the x squared. This next term, something cancels and I get just the 1, and then I have equals 5e to the x. So the next thing that I'm actually going to do, this one's a little bit tricky. I'm actually going to get all the e to the x's, all those exponentials, on one side of the equal sign. So that will become e to the x squared. Sorry, that's my dog. E to the x squared, and then do the minus 5e to the x plus 1 equals 0. Yep, that's what we ended up with. Because now that I have everything on one side, you should be able to notice that I've got over here, I've got a squared term. This is something to the power of 2, so that turns that into a quadratic. And in order to make it a little bit easier, I'm actually going to do what's called the substitution. If I were to let u be e to the x, then what happens there is this entire portion becomes now just u squared minus 5u plus 1 equals 0. So that's what that step does. So again, let me just show you one more time. Letting u equal e to the x, that turned this into the u squared and this into just a u, which is where we ended up with this quadratic equation below. So from there you can do one of two things. This is now just a regular quadratic. You could either factor, or you could do the quadratic formula. In this example I'm looking at it, I don't think that it factors, so you would have to do the quadratic formula. Once you did the quadratic formula, that would solve for u. So let me write down here, you're going to use the quadratic formula in order to solve for u. Once you do that, then that would give you a good start to the solution to this problem, is being able to use the quadratic formula there. Let's go ahead and do that, actually, using the quadratic formula. So instead of x equals, it's now u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And going back and looking at the problem that we have in question, we have my a here is 1, my b here is negative 5, and my c here is 1. So I may need to go back and forth here for a minute, but that'll give me negative 5 plus or minus. Okay, so that ended up with u equaling 5 plus or minus the square root of 21 over 2. So what did we end up with? That's what our u equaled. So again, this was our u equals. The problem was we needed to solve for x, though. So going back to remembering what we actually did when we let u equal e to the x, going back to that, we now have e to the x equals 5 plus or minus the square root of 21 all over 2. And then in order to solve for x, the only way you solve for x once you have e to the something equals a number was to take ln of both sides. And once you take ln of both sides, that'll give you just x on the left-hand side. And then I have x equals ln of 5 plus or minus the square root of 21 all over 2. And that is the solutions. And you can always go back and plug things into your calculator if you needed a decimal for that.